Hey guys, I'm Pat Kelly. Okay, and so this type of problem, what they're giving us is a group of letters, some of which might be repeated, and they're asking us to find the number of distinguishable permutations. If we were to throw all those letters in a hat, mix them up and pull them out, how many different permutations could we get? And they have to be distinguishable because, for instance, these three different E's, they all look the same, so you don't know which one's which. Okay. This is not too difficult for us because it comes down to a formula. We always like it when it comes down to a formula. So to start, my formula, I'm going to leave some working space here, okay? So give me some room to do some scratch work in a minute. But that go-to formula, which is always nice to have, is n as a factorial divided by n sub 1 as a factorial, n sub 2 as a factorial, and then dot, dot, dot. And I'll explain. What you need to know is for each of these different components of your formula, you got to know what to plug in and where to get it from. So to start, that n in the numerator, we're going to have as an n factorial. That's just the number of different letters. So 1, 2, 3, 4, 5, 6, 7. My n equals 7. More interestingly, maybe, the denominator, each of those factorials, you notice the subscripts. What you're doing is you're counting the number of different letters of the same type there are. So there are 2 different A's. My n sub 1 will equal 2. Okay? The G here, there's only one of them, n sub 2 will just equal 1. I'll try to keep switching colors if I can, if it helps. Here, there are 3 different E's, so my third n will equal 1, 2, 3. There are 3 different E's. And then finally, there's only one of these m's, so n sub 4 equals 1. Okay? Now you just put it all together. Switch over here to blue. This will equal my n, which was 7. I'll have 7 factorial in your numerator. My first n sub whatever, my n sub 1 was 2. So down here I'm going to have a 2 factorial. Then my next n was this n sub 2, green, I guess, 1 factorial. My next n, my yellow guy here, is 3 factorial. And then my last n sub whatever is n sub 4 is 1. That's just a 1 factorial. If nothing else, very colorful, right? And that's your formula. Now we just have to simplify it. We have to calculate it. Okay, so this will equal, if I go down, 7 factorial, I'm going to start breaking it down. 7 times 6 times 5. Go as far as you have to, and what you do is you look for the biggest factorial downstairs. I'm going to be able to stop at a 3 factorial. 7, 6, 5, 4, 3 factorial. Because then I know that's going to cross out, that's going to divide with that 3 factorial. Let's work out the rest of these. 2 factorial is just 2. 1 factorial is just 1. The 3 factorial, I'm not going to evaluate because I know that it's going to divide. And there was another factorial, but it's just a 1 factorial, which is 1. And now it's just a little bit of arithmetic, okay? Let's see if I could fit this down here maybe. This equals, and I think what I'd be doing here is taking the 2, divide with 6 to get 3. 21 times 20, 420 is what I'm getting in my head, okay? All right, hope that helps with some of the other problems. Of course, practice, but your n is the total number of individual elements, and then you have to break down your n sub 1, sub 2, sub 3, as many as you have, okay? And then set up this formula right there. Okay, go to it, try some on your own.